Hi, I'm Pat Kelly. Okay, here's where they give us one of these infinite series. See how the upper index there goes all the way to infinity, and they ask us to find just some partial sums. Specifically for this problem, the third, the fourth, and the fifth partial sum. And the whole idea of a partial sum is that we're not going to go all the way to infinity. Who has time for that, right? So instead, we only go 3 terms out, or 4 terms, or 5 terms. So your work for any one of these is to actually just realize that it's that same sigma notation. So I'll start with that sigma notation. But my I starts at 1 still, because that's where it's supposed to start. But I don't have time to go to infinity. I'll just go to 3. For the third partial sum, I'm just going to go to 3 for the upper limit of the index. And then inside stays exactly the same. And that becomes one of those smaller scale problems that I'm sure you've done some on your own, is we're just substituting the values for I. Let's go ahead and do that. Start at 1, 1/2 to the 1 power. A plus sign, and that's from the sigma concept, right? We're summing up a bunch of things. Move on and do that same 1/2, but my index bumps up to 2. Plus same 1/2, bump that index up. I keep saying index, that's what's in our exponent for this particular expression, so that exponent becomes 3. And I stop at 3 for this partial sum. And now evaluate, so we'll do a little bit of arithmetic here. It's actually just 1/2 plus 1/4 plus 1/8. And I'm still up for the challenge of doing some arithmetic. I don't think I need a calculator for this, right? Common denominator of 8. So this would be like 4/8 plus 2/8 plus 1/8. 7/8 looks good to me, okay? That's my answer for the third partial sum. They also want us to find the fourth partial sum and the fifth partial sum. I'll give you a quick tip here. Try to be smart with your work. I say that because if we're going to now find the fourth partial sum, after having found the third partial sum, realize that the fourth partial sum will be the third partial sum plus this expression from that series, but with the index bumped up to 4. So I'm just going to go to 1/2 parentheses exponent of 4. Right? Make sure you're seeing that that parentheses 1/2 to the 4th power that I just wrote would have been the next term right there. And that's why I can use it now for my fourth partial sum, is just pick up where you left off. That's right here, right there. But add this fourth term, okay? So let's continue. My S sub 3, third partial sum, was that 7/8 plus 1/2 to the 4th power. That's 1/16. And I still don't think I need a calculator, right? Common denominator 16, so I'll double that. 7 becomes 14 plus 1, 15/16 for my answer there. I'll just throw one last little color coding in there to keep it consistent. That 7/8 came from my S sub 3 is my answer there. Okay, same thought here then, even to save a little bit of work for the third one. They want us to find the fifth partial sum. I mean the third part of the problem. The same work of saying, hey, wait a minute, I already have S sub 4, and I'll just tack on one more term. What would have been the fifth term of this series? So 1/2 parentheses to the 5th power. Again, looking at the original expression, but this time the I would be 5. So my exponent is 5. So this equals my S sub 4. I'll grab that answer from a minute ago, 15/16. And I just add 1/2 to the 5th power, 1/32. So double these numbers, that goes up to 30 plus 1, 31, 30 seconds. Okay, there. All right, that's the concept of a partial sum, is you're only doing a few of the infinitely many terms. Okay, but you can build off the other ones once you've done, like S sub 3 to get S sub 4. Okay, hope that helps, but you know you have to practice some more on your own.